if I have a situation where some of the digits would have been the same, I would have to use a different formula. And so basically here, if they're not all distinct, then I would use this formula here, where basically the number of permutations would be based off of me saying, okay, n factorial over n1 factorial, n2 factorial. So it depends on how many groups I have that repeat. So for instance here, how many different signals can be made by hoisting 2 yellow flags, 4 green flags, and 3 red flags on a ship's mast at the same time? So here, each yellow flag is going to look the same. So those really don't matter which order there are. So you have 2 that are in the group for yellow flags, 4 in the group of green flags, 3 in the group of red flags. That means you have a grand total of 9 flags. Out of those 9 flags, how many different ways can they be raised to produce a different sequence of colors? Is what you're looking for here. So I have 9 flags total, so the overall n is 9. I called n sub y for yellow is 2, n sub g is 4, and sub r is 3. And so when I want to figure out how many different signals, it's going to be n factorial over ny factorial times ng factorial times nr factorial. So it's going to be 9 factorial over 2 factorial times 4 factorial times 3 factorial. When I work that out, I get 1,260 different signals. So, you have basically 1,260 different messages that could be created, and as long as you know what those combinations of flags represent, you could communicate certain things that are going on the boat based off of the way those flags are raised.